Okay, now we have this trait that we talk in the class about, that is albinism, that is a simple recessive trait, and now we have to determine genotypes and phenotype of the parent of the offspring for the following families. So one, that you have two non-albino parents, and you have 5 children that are 4 typical and 1 albino. And in the other case, you have a typical male and a female that is albino that have six children, all typical. So how you can get those things? So let's start answering. So remember, the albinism is a lack of pigmentation in the eyes, skin, and hair, and it's an inherited condition, and is the combination of two recessive alleles. So, for example, if you see here, they don't talk that is sex linked, so it's an in the autosomal gene. And when, for example, these parents are both carriers, you can have one kid here that is affected. Here, these two kids are carrier, and this one it will be not affected. So now we have to translate that into a Punnett square. In this case, that you have two non-albino parents that have children that 4 are typical and 1 is albino. So how do you get those? So this is pretty easy. So you have two non-albinos. So suppose that this is the male and this is the female, and both should be recessive. Why? Because you have 4 typical. So if you have the two albinos, you get one that is typical, that is 25%, one that is the carriers that are 50, so 1 and 1 here, and the albino that is 25%. So in other words, you get these ones. They don't tell you how many carriers, they just tell you that they have 4 children, and here, so this 4 plus 1, so have 5 kids. 4 of them could be typical or carriers. And 1 should be albino. They don't ask you, they don't define, I don't know, they don't define if the typicals are also only are carriers or or lack the albino gene. So this is perfect. Remember that these are just proportions, and as we have so few samples, only 5, we don't get the perfect 25%, 50%, and 25%, but actually we got very close to that. Now let's go and solve the other. Okay, before solving the other one, I have this exercise that show you why the other option is wrong. So suppose that this is the male and this is the female, so you have a female that is a carrier and a male that is a typical but not a carrier. And if you have that, you have no option to get albinos. Yeah, the albino genotype or albino phenotype. So in this case, this is impossible. So this is wrong. Yeah, this typical has to be the carrier one. They want those parents. Now let's answer this one. A typical male and an albino female have 6 children, all typical. Okay, so typical male here and an albino female, and remember, if they're albino, have to have a homozygous recessive, have 6 children, all typical. So they are asking you, okay, what do you think that is? Is the typical male, is this one, or is a carrier that have a typical phenotype? And So here you cannot get heterozygous. You cannot get homozygous recessive. So this can perfectly fit there. Yeah. However, here if you get this one, that's this female, and this that is a carrier, here you're going to get a 50-50 chance of getting a carrier that is typical and albino. So this one will be the carrier, and this one will be the carriers, and this one will be the albino. So is this possible? Yes, that this could be the option. Yes, but it's very unlikely. Yeah. But remember, uh, as we have so few samples, yeah, here you have 6 children. So it's like you flip the coin 6 times and you always get tail. Is possible? Yeah. Is less likely? Yes, it's less likely that the other answer. But this could also take place.